Welcome to this presentation about the subatomic swirl. Let us start with the swirl. So what is a swirl? Just think about the airflow in a tornado. When a spread of matter is moving in a spiraling pattern, a swirl forms. Many think swirls such as the pancake mix being stirred up or our home galaxy, the Milky Way. Have you ever wondered what is the world's fastest spinning swirl? It turns out the latest champion is a subatomic swirl that was discovered recently. Let us explore what it is. So, what are the subatomic stuff? To begin with, think about any normal stuff, like a drop of water, an apple, or an ice cream cone. All normal stuff are ultimately made from the very small entities known as atoms. However, as physicists found over the past century, the atoms themselves are made from even smaller parts, which are the subatomic particles, such as quarks and gluons. These quarks and gluons are the basic building blocks of everything in our physical world. Just think about playing with Legos. The subatomic particles are like one handful of basic Lego figures. By putting many such pieces together, one can make millions of wonderful creations. In fact, these subatomic particles hold the key to understanding our cosmic history. Ever wonder about how our universe began? According to the current physics theory, the universe was born after a violent event called the Big Bang more than 13 billion years ago. Shortly after this happened, the early universe was so hot, its temperature at the time melted everything into a super hot soup of subatomic particles. This subatomic soup is called a quark-gluon plasma, or QGP for short. It can only be formed in a very hot environment, in fact, only at a temperature as high as 1 trillion degrees or even more. This is a temperature that is about 10 billion times hotter than our typical room temperature, or almost 1 million times hotter than the very center of the sun. But the time of the early universe was long, long ago. How could we possibly make something this hot today? Well, physicists are smart enough to figure out a way by building a giant machine called a high-energy collider to do this. One such machine is located on the Long Island of New York in the United States, called a Relativistic Heavy Ton Collider, or RHIC for short. It was built by the Brookhaven National Laboratory, a facility of the U.S. Department of Energy. At RHIC, scientists accelerate the atoms, or more precisely, the nucleus cores of atoms, to move along the inside miles of tunnel until they run around almost as fast as light. Then they smash these atoms together, referred to as a collision events. Just like in a car accident, the smashing converts the huge amount of energy carried by the moving stuff into a fire, thus making a very hot spot where the quark-gluon plasma is produced. The QGP created by such a collision holds the Guinness World Records for the highest man-made temperature. There is, however, a big challenge for our adventure into the subatomic world. These subatomic quarks or gluons are just too tiny to be seen by eyes, or even by any usual microscope. Physicists have built dedicated detectors, geared up with modern technologies with very specific purpose for capacity for spotting subatomic particles that fly out from the atomic smashing events. One such superb detector is called STAR, an acronym for the phrase Solenoidal Tracker at RHIC. The STAR detector allows the collaboration of some 500 scientists from all over the globe to be able to peek into the hot quark-gluon plasma and unravel all mysteries of the otherwise inaccessible subatomic world. The picture on the lower left corner shows an example of the detection for a particular particle called the lambda hyperon out of the thousands of particles that emerge from the collision. The latest exciting discovery from the STAR collaboration was the subatomic swirl. Reported in the August 3rd issue of Nature, its cool discovery was featured as a cover story. The social news about subatomic swirl quickly spread on the news outlets and social media, generating a wave of enthusiasm. So exactly what is so cool about the subatomic swirl? By a very clever method, the STAR scientists measured a property called global polarization of the lambda hyperon mentioned before, the results shown in the left figure. From that, they then extracted the spinning speed of a subatomic swirl an astonishing number, about 6 trillion rounds per second. That is, the QGP is swirling a billion times faster than a race car engine at the Indy 500. It is a remarkable phenomenon now referred as the most vortical fluid. Theoretical physicists around the world have been busy cranking their computers to figure out the swirl structure. At Indiana University, the QGP research group uses the IU Big Red 2 supercomputing facility to map out the swirling QGP and examine its consequences in great details. The figures here are showcasing some of the notable results from these IU researchers. Interested in finding out more cool stuff about the hot core gluon plasma? Find the web pages shown here. Thank you for watching.